And for your help. We got.
Okay, so for your homework, question page 448, questions 13 to 17. If you actually read the stuff in front of question 13, you would have saw you're not supposed to solve, but you're supposed to answer the question: how many solutions for those problems, those systems? Okay. Now that one's a little bit hard because I'm telling you turn into y equals mx plus b. But you're not exactly sure on which one's x and which one's y because you're using different letters like d and n and other things. So the alternate thing to check is ax plus by equals c. So what you're checking, if you have the same line, your equations will have a same a and a same b. Of course, you can have equivalent numbers, and you'd have a same c. You should be writing this down, folks, not just staring at me. Although I'm sure it's easy on your eyes, but please do write this down, okay? For a parallel line, you'll still have the same slope. This stuff is all here your slope. And this last c is your intercept. However, for parallel lines, this will be different. Now, if you have one solution, because you have different lines, then all you're going to have is one will be different. You either need a different A or a different B. C doesn't matter. You wouldn't need to check C. Okay. Now you got to be careful because you are going to have equivalent equations. And that's where it gets a little tricky. So there's a short way to check this. So if I have 3x plus 2y equals 10, and then the other equation is 6x plus 4y equals 20, a lot of you people are going to say, yeah, they're exactly the same line. Now, assume we had harder questions. You would quickly go 6 divided by 3 equals 2, 4 divided by 2 equals 2, and 20 divided by 10 equals 2. So now you'll know that they have the same, they've increased by the same factor. Right? And that can help you say, hey, they are the same equations. This is the same line. They're all increased by the same factor. All right? The next example, if we have 3x plus 2y equals 10, and then we had something like 6x plus, sorry, let me try this one here, 9x plus 6y equals 21. So if you're checking this one, now always go the high number divided by the low number, always you get decimals. Okay, so you could have gone 2 divided by 6, you just would have got decimals. Then 21 divided by 10, if you check that one, it's 2.1. Okay. So what happened here is you have the same slope because both A and B were increased by the same amount, but your intercepts are different. So this would be parallel. Okay, so this would be same line. Same lines. This one would be parallel lines. Okay. So then an example of one solution would be 3x plus 2y equals 10. And then you got 12x plus 7y equals 40. Right? And so you go 12 divided by 3 equals 4. 7 divided by 2 equals, I don't know, 7 divided by 2. That equals 3.5. So right away here you can say these are different lines. One solution. I don't even bother checking C because C could be the same or not. It doesn't matter. But if I have a different slope, those lines cross once, one solution. Okay. So I would only use this, turn it off, I'd only use this if I had letters other than X and Y. I wasn't sure which one was my Y value, okay? But for X and Y, it's really easy. Turn it into Y equals MX plus B. If you're working away and you get 0 equals 0 or 0 equals 4, guess what? You better turn to Y equals MX plus B because you either have the same line or you have parallel lines. Right? If you can't solve it, you got one of those instances and you got to tell me which one. All right? Any questions? So this one's similar to what we have had already, though we have now a revenue. Okay? The revenue is just how much money you bring in. So revenue for a store is going to be price times the quantity. Now, what we see today is that sometimes we're going to have to find the total revenue, and so you're going to have to total up price times quantity, because you might be buying 2 things or 3 things. Well, only 2. I won't lie to you. Okay, so reading the question, there's 36,500 fans, 2 ticket prices, 35 and 20. The total revenue was 940,000. Now the questions are going to help you. How many $35 tickets and how many $20 tickets were sold? So what we can do is do an if-then statement or make a legend. If X equals the amount or the number of $20 tickets, then what would Y equal? The number of $35 tickets. Okay. Now we're going to assume there's no scalpers and everyone bought a ticket, went to the game. If everyone bought a ticket and went to the game, there's equation number 1. The number of tickets at $20 plus the number of $35 tickets equals the total number of people at the game. Kind of makes sense because you need a ticket to get into the game. So that's equation number 1. X plus Y equals 36,500. The second equation is the revenue equation, $940,000. So how would you get your revenue? Price times quantity. So $20 times X plus $35 times Y. Okay. There's your 2 equations. Very similar to what we did yesterday, just bigger numbers. So change them so you can solve. 20x plus 35y doesn't get changed. So what do you want to multiply the top one by? Jordan? 20. Sounds good. Your choice. Could have been 20 or 35. He said 20. So we'll go with that. So you're going to get some large numbers here. Be careful. Make sure you have the correct number of zeros. Subtract them. Don't worry about the negative because you have 2 of them, which will give you a positive answer once you divide. So negative 21,000. So then we can divide. And you get 14,000. So 14,000 people bought the expensive tickets. What should we do now to find X? You could do elimination again. Michaela?
Just a question. Where did you get the 730,000?
What we do is we multiply this entire equation by 20. So each term is multiplied. Okay? So what we're going to do now is substitute and solve. So instead of x plus y, it'll be x plus 14,000 equals 36,500. So that's from equation 1. and then solve for x. And so 22,500. And you have to tell me what x and y stand for. So you're going to say 14,000 at $35 tickets. Somehow you have to tell me how many there are. And 22,500 at $20 tickets. Okay. Somehow you have to tell me how many there are. And there you go. Any questions? It's very similar to yesterday, kind of like the coin questions. Okay. We just have bigger numbers. Next one, concentration one. So this one's new. We haven't done this one before. So it's solution by volume. Okay. So first of all, there's two concentrations. So what we like to do is I like to draw beakers. If you draw your beaker, it's hard to get this one wrong. You have two beakers that get added together, and then you make a total solution. So you have, in your last beaker, you have 400 milliliters. That's your volume. And the concentration of that is 60%. But we don't use 60. What do we use? Yeah, 0.60. Okay. Now, what's the volume of the two solutions? Do you know the volume? No. It's asking for that. It says how many milliliters of each solution. So, if x equals the volume equals, let's say, milliliters of 50%, then y would equal the volume, or milliliters, of 100%. Okay. So, to match the last beaker, we would put x plus y on the top. That's how much we used. We don't know it. We're trying to find it. Okay. For the concentration, though, the concentration would be 50%, or 0.50. That would be for the beaker that we used x amount of. What's 100% as a decimal? 1.00. So that would be the concentration of y, of how much we don't know. So our two equations are as follows. X plus y equals 400. So the first one is going to be a volume equation. This one's volume. The next one would be concentration equations. So this one would be 50% concentration of x plus 100% concentration of y equals 0.60 times 400. That's new. You guys want to know which part you're going to forget to do? This part. That's the part most of you will get incorrect because you go too fast and don't use proper numbers. Okay? So I'm telling you right now, be careful with that last part. So math-wise, what you could do is multiply that together and go 0.6 times 400 is 240. So we get 0.50x plus 1.00y equals 240. You didn't have to do it right now. I just thought we would. Okay. What we should do is get rid of our decimals. What can we multiply by to get rid of our decimals? 2 decimal places? 100. So we had 50x plus 100y equals 24000. Okay. What should we do to the top equation so we can eliminate? Multiply by Jordan? Yeah, 100 or 50, your choice. Alina? 100. Sure, sounds good. So multiply by 100. So we get 100x plus 100y equals 400, and then 2 more zeros. 40,000. Okay, go ahead, solve. Finish it. So x equals 120. And then I'm going to use the original equation, x plus y equals 400, and substitute it in. So y equals 280. Oh, I thought that was off. Thank you. $320, yeah, that's right. So y equals 80. So now you have to tell me how much of each different type. Okay, so 80 milliliters of 100% and 320 milliliters of 50%. Make sure you have your units. There you go. Any questions? Which part do you usually forget? That last beaker part. Okay, it's a multiplication right there. All right, turn it over. So here we have some dirt questions. They're very dirty. By dirt, I mean distance equals rate times time. Now this is what you need to remember. Dirt. Say it to yourself. Dirt, 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 dirt. I hope you use your inside voice because you sure didn't use your outside one. So, in science, you've been taught this formula pyramid. Distance is on top, rate times time in the bottom. You just need to remember dirt. So what would the rate equal then? Cover up the R, what's left over? D over T, which means distance divided by time. Okay, so this is distance equals rate times time. So if you're going 100 kilometers an hour for 3 hours, how far did you go? 100 times 3 is 300 kilometers. Okay. Okay, what about time? What does that one equal?
Distance over rate.
Good, distance over rate. All right. So here we're talking about a boat on a river. With the current, you would add the speeds. That's how it works. If you're traveling from Abbotsford to Langley on a boat on the Fraser River, you're going to be going really quickly because the river is going so fast and your boat's going fast. The speeds are added. But when you get to Langley and turn around, now you got to fight the current and you're going against it. Well, guess what? You would have to subtract the speeds. Okay. It's 10 times as hard now. Now you got to paddle up that river. Has anyone done that on the Fraser River? I have with a canoe. It's crazy hard, right? You're paddling like crazy and barely moving anywhere. Okay, so keep that in mind. Now the same thing is with wind, right? If the wind's behind you, you're going to go really fast, but if the wind's in front of you, you go really, really slow. That's why when they talk about the Olympics and the World Championships for 100-meter dash, you only have a certain amount of tailwind and headwind, or they don't run the race, right? Because it's not fair then, right? Okay, so here we have with the current and against the current, and we have dirt. Distance equals rate times time. It's just a little small. Still a little small. I'll move that down a bit. Okay. So, what's the distance that the boat traveled with the current and against the current? It was the same distance both ways, folks. It went up the river and back down. Okay, so going up the river, though, how long did it take when he went against the current? 5 hours. And when he came back with the current, how long? 3 hours. Okay, good. So when you X, it says here, find the speed of the boat in still water and the speed of the current. So X equals speed of the boat. Then Y would equal speed of the current. So when you're going with the current, you add the speeds up, X plus Y. When you're going against the current, you subtract them, X minus Y. And trust me, the boat has to go faster than the river, so it's going to be larger, right? Otherwise, you won't travel anywhere up the river. Okay, so here's equation number 1. There's equation number 2. Now you have your choice here. How you model your equations up to you. Because you have both variables, in those lines, that's the way you make up your equation. Our next example is not going to be like that, okay? So first of all, we can do distance equals rate times time. For that equation, we would say 60 equals bracket X plus Y times 3. And for the second one, 60 equals X minus Y times 5. Okay. For the next equation, we could use rate equals distance divided by time. So we could use X plus Y equals 60 divided by 3 and X minus Y equals 60 divided by 5. So we could use that one as well. Okay. Either or. Now don't write this next one down. Okay, this next one, we could say time equals distance divided by R. So time would be 3 equals 60 divided by X plus Y. Whoa, what? 6 equals X minus Y. Those are really, really hard for you to do because we haven't really done a lot of those. So I wouldn't recommend that. Now, others, it might work out easier. Depends where X and Y are. Okay, where they are located. For us, I wouldn't use it for this question. Okay, the chart helps you organize your work. So, rewrite this one. X plus Y equals what? X minus Y equals what? This would be 20. And what's the next one? 12. Is that easy to work with? Yeah. What about the other one? 60 equals 3x plus 3y. 60 equals 5x minus 5y. Are those easy to work with? Good answer. Not as easy. Okay, so it's your choice, whichever one you want. But I think the right side's easier, so let's work this one, okay? Easy. You don't have to make up all the equations. You just choose which ones you think you want to work with, okay? I just showed you both examples. You choose either left or the right. Okay? So go ahead, solve. Most of you, I think, are going to work with this one. So I would do an addition or a subtraction. X equals 16. That's easy. Then you could substitute in. So 16 plus y equals 20. Y must equal 4. Okay. So, speed of the boat is 16 kilometers per hour. And speed of the current is 4 kilometers per hour. Okay, there you go. Put it in a little box, easy for Mr. Barker to find. Okay. Yes, Alina. 20 plus 12. Okay. So always set up your chart dirt. Distance, rate, time. Okay. Now, Milton took 5 hours to drive 470 kilometers from Regina to the Hat. Part of the trip was at 100, the rest was at 90. How far at each speed? There's X and Y. So, if X equals the distance at 100, then Y equals the distance at 90. Where did I find X and Y? Found in the last sentence or the question. Okay, so when you're stuck, what's X and Y? Where should you look? The last sentence. Often it's there, sometimes it's the first sentence. Okay, but it is in the question somewhere. So, this will be at 100, this will be at 90. What should we put in here for D? That would be X, because we don't know what it is, and we just said it is, the distance. For at 90, we don't know how far he traveled at 90, so it's Y. But how far did he travel total? No, 470. So this is something different now. We know the total, okay? Now what about time? Well, it doesn't say anything. What about rate? What was the rate that he drove 100 kilometers per hour at? Yeah, 100 kilometers per hour. That's like my daughter's baseball coach. She got, anyways, the answer is mouse, by the way. Okay. So at 90 kilometers an hour, the rate was 90 kilometers an hour. Now, this is what's a little bit weird for this one. What would be the time? Sorry? Well, have a look up top. Is there a way to find the time? Yeah, distance over rate. So for us, time equals distance over rate. So that would be X divided by 100. Here it would be Y divided by 90. What's the total time of the drive? 5 hours. Okay, so that's set in the question at the beginning. So, if you're looking at this top line right here, do you have an X and a Y in that line? No. Do you have an X and a Y in this line? No. So those can't be our equations. Our equations now go vertical. Do you have an X and a Y in that line? Do you have an X and a Y in this line? Yes. So those are your two equations. Let's make this one equation 1. X plus Y equals 470. And equation 2. It's a little bit harder, but we're going to change it right away. X divided by 100 plus Y divided by 90 equals 5. Okay. So, what should we do to get rid of those fractions? Multiply by what? 100, 90, 900. Multiply by 900. So really, you're going 900 divided by 100 on your calculator, because we know we can't do math. 900 divided by 100, 9. So we have 9x. plus. Oh, now Mr. Barker said 900, so 900 divided by 90, 10. Oh, 10y. That's easy. Oh, what's 900 times 5? Oh, 4,500. Okay. Hey, guess what? Fractions are gone, folks. Not too bad. So, what do you want to multiply the top one by so you can start eliminating? Sarah, what? Sure. Or, which one do you choose? Sure, whatever. So, she chose 10. That's what we'll do. 10x plus 10y equals 470 and one more 0. Ah, easy peasy. There you go. Solve it. Go. And answer the question. Okay. So, you would want to subtract and get 1x. Well, that's easy. Equals 200. Okay. So then I'd substitute into x plus y equals 470. I mean, that's the easiest version of the question you have. So I'd put that in there. And so y equals 270. Okay. So what's the answer to the question? Yes, Alina, ask. Well, you could, but instead of using this one, Alina, so I know, sorry. Instead of using this one, I just use the simpler one. Okay, and just because it's simpler. But you doing that one works too. You will get the right answer. Okay. So I would say 200 kilometers. It's the distance, right? That's what my if-then statement says. Distance at 100 kilometers an hour. And then the 270 kilometers, that's at 90 kilometers per hour. Okay. Questions? So, today is your lucky day. Here's your homework. Friday, May 24th. No textbook work. You're just doing the handout. Now, your handout's attached. If you look at it, you got some easier questions. But I want you to start on 16. Do 16 to 21 first. Those are the hardest ones. Once you've done that, the rest I don't think you'll have a problem with at home. Okay? So start with those ones. Have your notes out. We're just changing numbers, okay? Have your notes out, follow along, ask me questions. You should be able to get those ones done before you leave, at least. Okay? Questions, comments, concerns? Complaints? Oh, that opens up at 3 o'clock. We'll see you then. Okay. Get to work. Go.